Today's lesson is on translations. A translation is a sliding of a shape from one location to another. The pre-image is the original shape, and the image is the shape after it has been slid. Prime marks, they look like apostrophes, are also attached to the vertices in different images. And I will show you what that means. So basically, translations, they're going to tell us where to slide it, and we're going to slide it. So there are two different ways to show notations of sliding. The first one is coordinate notation, and the second one is component notation. Two different ways to look at something to know where we're going to slide. So in our first example, it says right 2 units, down 4 units, and we're sliding these shapes on the coordinate plane. So if we're going right 2 units, and we're talking about coordinates, we want to have coordinates look like a pair of coordinates. Parentheses around, you're going to have an X and you're going to have a Y. And in this right 2 units, if I'm moving to the right 2 units, that would be in a positive direction. So X plus 2. When I go down 4 units, that would be in a negative direction. So Y minus 4. And that would be coordinate notation. Another way you could see this is called component notation or vector notation. And these have your angled brackets, kind of like a greater than, less than. And they don't put the X or the Y in there. They just put the fact that it's a positive 2 and it's a negative 4. I'm going to skip this middle one because I want you to try it. Actually, I will do it. So for this one, it's going to be left 5 units. So that would be X minus 5. And then up 3 units, Y plus 3. Parentheses, regular parentheses. For the component notation, we're going to have our angled brackets. The negative 5, remove the X. The positive 3, remove the Y. For the last one, it just says down 4 units. There is no left or right movement, so therefore that value is going to stay the same. So the way we would represent that in coordinate notation is just by putting whatever the X value is, because it's going to stay the same. And then our Y value would be minus 4 again. As we come down here into the component notation, if the X value stays the same, we don't move it at all, so that means a 0, and then our negative 4. So that's the ways that you write coordinate notation and component notation. When we go to the second part, we're going to be given a shape. We're going to be asked to translate it using this vector notation or component notation, and then draw the new shape. We have a pre-image. This is our pre-image. We are going to create the image. We are going to put the prime markings on there, and on the vertices or the vertex. So in the first example, it tells us to move this shape -1, +3. So that would be 1 unit to the left, because that's in the X value, and then 3 units up, 1, 2, 3. We're going to make our new point, and we're going to label it W, and then here's my prime. It looks like an exponent of 1 or a little apostrophe. And we're going to do that to each of the vertices or the corners. The X value, 1 to the left, 3 units up. And we call that X prime. Y, 1 unit to the left, 3 units up. And we call that Y prime. Just like an exponent of 1. Z, 1 unit to the left, 1, 2, 3 units up. Z prime. And you'll notice when we connect the dots that these shapes remain on each other. They share kind of parts or sides. Many of your designs that you see on clothing brands use translations and reflections and rotations that we will be getting into. So there's our first one. I'm going to allow you to try the second one, and I'm going to ask you a question in a minute about that. Let's look at this second translation where it says x minus 2, y plus 1. So we're going to take each one of these and we're going to go x minus 2. So minus 2, 1, 2, and then plus 1. And we have m prime. And 2 to the left, 1, 2, 1 up, n prime. O, 2 to the left, 1 up. That puts us right at the origin, O prime. And then P, 2 to the left, 1 up. Puts us over here at P prime. We would make our new shape. Notice again that these do overlap. That's another example. In the third example here, it is, we've got both images already done, and it's asking us to name the translation. I know it might be hard for you to see, but this is the image, S prime. I think that's a P prime, and this is a Q prime. So we have to figure out how did we get from the pre-image to the image. And we just go from S to S prime. And let's count. 1, 2, 3, 4, 5 units to the right, 1 unit down gets us from S to S prime. So if we did it in component, it would be 5 and negative 1. If we did it in coordinate form, it would be x plus 5, because we went to the right, and then y minus 1. Put those in parentheses, and these would be the rules or the translation that we did. And you could have picked any point. Let's check. Point P, 1, 2, 3, 4, 5 units to the right, 1 unit down. Q, 1, 2, 3, 4, 5 units to the right, 1 unit down. So they will all match up. And the shapes do not change. They just slide across. I'm going to give you some opportunities to do some practice here. And I'll start you off on the first one, J. I'll just group J. 5 to the right, 1, 2, 3, 4, 5 to the right, 1, 2 units up. And this would be J prime. Why don't you continue with K, L, and M? For the fifth example, x minus 2y plus 3, I'll do B. X minus 2, 2 to the left, 1, 2, 3 up, and this would be B prime. And then for this one, I'll let you know that the pre-image is the darker. So this is the pre-image. And the lighter version is the image. And it looks like we have a T prime here, a K prime here, a Q prime here, and a C prime here. And that is how you do translations. As we slide down one more last little bit, the point J, -4, -2, is translated by a vector of 6, 0. What are the new coordinates? So what we are going to do is we're going to add, we could start on the coordinate at -4, and we're going to count 6 units over or add 6 units. It would take us to +2. So it's kind of like adding a -4 and a +6. The new coordinates would be, now these are coordinates, so they're in parentheses. -4 adding 6 would be a +2. A -2, making no change at all, it would remain -2. If we're at -4, -2, and it's translated by a vector of x plus 6, y minus 2, well, we notice that the x plus 6 is the similar to up top. So again, -4 plus 6 would be +2. -2 and another -2, that would make it -4. If we're starting at 0, 0, James travels 20 miles east and 15 miles south. What is his ending coordinates? We did this one the other day. We remember that east is heading to the right, south is heading down, so it would be positive 20, negative 15. And if he travels 25 miles east, 17 miles south, and 10 miles west, we added another coordinate in there. We went 25 miles east, 25, 17 south. So that first one would be 25, negative 17. But then we came back 10 miles this way. So it would be 25 minus 10 would be 15. So 15, negative 17. I hope this helped. Translations, just sliding a shape using either coordinate form or component form. Have a great day.